I am now at Heceta Head National Historic Site, and I'm panning from the Cape Creek Bridge, which is what 101 crosses, and I'm panning to the west now. And let's go in a little bit closer maybe. And we're gonna walk over there closer to this cliff face. Now around the corner on this headland is Heceta Head Lighthouse, and that is the lighthouse keeper's house, which there's no lighthouse keeper anymore. So that is now a privately run bed and breakfast, which is supposedly haunted. And I'm standing on a sandy beach, but at the top part of the beach, is littered with pebbles to cobbles size pieces of weathered basalt. So look at how rounded the edges are on these cobbles. And you can see bits of shell material, little tiny pieces of driftwood. There's a couple of feathers, probably from a seagull. Okay. Now most of them have that kind of shiny bluish gray look. Every once in a while you'll find one that looks like this, and that coloration means that that one has undergone a lot more oxidation. You can see the difference on this broken cobble of the weathering rind, that oxidation, compared to the actual color of the basalt itself, which is very dark gray. We also have at this beach, and I'm going to go over to another one, some basalt that is what we call porphyritic. Porphyritic means that some of the mineral grains are actually big enough for you to be able to see them, and they're floating in a fine-grained ground mass. So those long white streaks, which have maybe some sand grains embedded, those are a type of mineral called plagioclase, and the plagioclase minerals have undergone chemical weathering, and so they're falling apart into clay, and so there's like little divots in the rock where those minerals used to be. Now here is a good-sized piece of basalt. I mean, this one's, here's my foot for scale, and I got a size 7 foot. Okay, and it looks very different. It's not smooth, is it? It has a lot of texture, and it has, down on this end, it has a lighter colored gray chunk. That's sand here. That light stuff is sand. But it has a lighter colored gray chunk kind of embedded in it. I'm going to talk about that when we get down closer to the cliff face. So this is the modern beach, right? Where you have a wide area of sand, and then there's the cobbles up mixed in at the top of the beach. And depending on where you are, some areas of this cobble area, the cobbles are quite thick. I think one of the reasons that it's not quite thick here is because this is where people, humans, walk down onto the beach. And sorry to say, I have a few cobbles. Well, I have at least one basalt cobble from this beach that is my doorstop at Lane Community College because it's so big. It's nicely porphyritic. And so I'm as guilty as anybody else of denuding this cobble beach. But if you get up into this area though, look at how much thicker the layering of those basalt cobbles is on the sand beach. Now, not everybody takes them away, right? Some people just move them down further into the surf area. So we're gonna walk over there towards this sea cliff. And why is this beach here? This is what we would call a pocket beach because it exists between two headlands, two areas that are sticking out towards the coast more. Waves, as they come into the shore, the wave front will come in and it will hit that headland first. And the parts of the wave to each side of that headland will start to curve in towards the headland. We call that wave refraction. What that ends up doing is putting wave energy, erosive energy, against the sides of the headland. Now it's still a little bit hitting the front of the headland where the wave front came in and hit it, but if you have both sides coming in towards the side of the headland, then that's going to be that much more activity to the sides of that projection of stone out into the ocean. Sorry about my trouble tripping there. I'm going over the creek trying to stay on the cobbles so I don't get my feet wet. And for whatever reason, there's a seagull that has decided to nest here. Notice the dark color. It looks purple in this stream. And there's an oxide stain where that water had been running out into the rest of the creek. Now, this could be two things. This could be the oxidation. Notice how many more of these cobbles up here are discolored. Okay, so it could be the oxidation of the cobbles, and you can see them buried. See how they're buried in the layer here, the soil layer? So there's sand and cobbles mixed underneath this vegetation. And so some of this discoloration is probably from the oxidation of these basalt cobbles. But it kind of has almost an oily sheen to it when you're here looking at it. And that leads me to believe that not everything in this water is naturally put into this water. Notice the bag. So we do have an older, now closed bathroom up in the parking lot at this place that they had to close because they had issues with it leaking. So I'm not quite sure why that discoloration is. I don't think it's all just oxidation of the cobbles. Okay, and you can see again, the cobbles bound up in the actual soil horizon. And then down further, there's another bit of cobble-covered beach. This area used to be a state park. It's now run by the federal government. It's a national site because the Heceta Head Lighthouse, the light in that lighthouse was still working. I think it still is. And it is a very special type of lens. And there simply aren't that many lighthouses that still use that type of lens. And therefore, it was considered a national historic site. And that's why the federal government is now taking care of this area. It used to be called Devil's Elbow State Park. Why is that? Well, it's because of that sea stack out there. See that pointy sea stack? Let me zero in on it even more. Okay. It doesn't look very black now because birds are on it. It's a nesting site. And the bird guano has turned it kind of white. But it is made out of basalt. And basalt, being black, many times natural features made out of basalt have been called by European settlers, shall we say, the devil's this and the devil's that. Okay, like you have that big, huge volcanic plug of a big volcano in Wyoming called Devil's Tower. And we're gonna see up at Cape Perpetua a place called Devil's Churn. So that's probably why this sea stack was called Devil's Elbow. Okay, now in the not too distant past, the second bigger sea stack used to be connected to the actual headland with an arch. That's the natural progression of weather or erosion by the waves of a headland. You get that refraction of the waves around the headland, so you get erosion in the sides of the headland on each side, and eventually you get caves forming. And in fact, we have, you can see in the distance here on the headland beneath those two trees, you can see this small cave. And if that happens at the sides of the headland, then eventually the caves will meet underneath. And if that opens out into a wider area so that you can see through it relatively easily, you would call it a sea arch. Eventually, the arch is going to get so fragile and thin that it's going to fall in, and then you end up with the rocks being separate. Okay, like these two sea stacks were probably at one point connected by an arch, okay? But it has since fallen in. And over here, they had an arch that went from that sea stack to the mainland. But when they had people start coming to this spot for recreation purposes, about the same time, they designated all rocks like this off the Oregon coast as marine bird sanctuaries. So to keep people from walking out on that big sea stack and bothering the birds, plus they wouldn't have wanted to have the financial burden of somebody falling off the arch and hurting themselves on the rocks below, so they destroyed the arch. It was destroyed on purpose to keep both things from happening. You know, the birds happier and also the people from getting injured. So now it stands as kind of a separate sea stack. At high tide is low tide right now. Not one of the lowest tides you're ever going to see, but it is low tide. All of these rocks here in front of us would be pretty much covered in water at high tide. So at high tide, that sea stack is actually separated. There's water between it and the headland over here. Okay, but right now, you could walk up on that sea stack. However, there's a sign right on it, maybe you can see it, that says don't, because it is a bird sanctuary. So remember when we were looking at the cobbles in the beach, and I said that there was that one dark cobble that had a different texture and it had a lighter gray cobble inside of it. That's because we have a couple of different kinds of basalt here at Heceta Head. This stuff that I'm looking at down below here, see how the texture is different than up above? So the layer below, most of the stuff below and out there in that wave cut platform, is a basalt flow. This is a basalt flow too, but this basalt flow, this younger flow, has incorporated pieces of rubble from an older flow inside the younger flow. And when it does this, we call this a volcanic breccia. And breccia implies that the pieces that are enclosed by a younger substance are rough. Okay, they're not nicely rounded or anything like that. Now you can see the kind of round holes in this lighter brown flow, and that's where those little cobbles have eroded out. Okay, and they've left a little hole. Now we're in the upper intertidal here, and so these rocks have a lot of little tiny barnacles. on them. They can live in the upper intertidal where they don't get much water at all because they can close themselves up tight and keep themselves from drying out. So here's more of that breccia. And then we have a really big sea cave. Okay, and you can, do you mind if I photograph you?
Go ahead.
Okay. So this is where these rocks used to be part of the hillside, and then they have fallen off because they've been undermined. If you hollow out like that, and you can see these natural fractures in the rock, eventually you're going to get pieces of that rock falling off and becoming part of the rocks that are down in the beach. So I'm going to keep on walking. And you can see how the rocks down here look smooth, right? And they've eroded to that lighter gray. And the rocks above are that rough volcanic breccia. And above that, we're back to probably the upper part of the flow where it's smooth basalt again. Now, how about above that? We have a relatively thick layer of oxidized sand. Okay, so there's sand is orange because iron minerals in the sand have oxidized and created basically rust. We call it hematite. But it continues, not quite as much oxidation over in that part of the sea cliff. But what we call this is a sedimentary rock that's up on top there. And when we have rounded cobbles enclosed within smaller sediment, like sand, and made into a rock, we call that a conglomerate. Okay? Well, that conglomerate, how did that sediment, what circumstances? Ooh, that piece looks like it's gonna, see how there's that big crack behind that piece? It's gonna fall off the cliff face someday. Looks like the vegetation is actually helping keep it in place. Okay, so how do we make a conglomerate in this particular situation?